Hello students, welcome to my YouTube channel. In this video lecture, I am going to answer DME questions from Keith Williams Radio Lab. So let's begin. Question number 71. The DME counters are rotating continuously. This indicates what? So very simple question. We have solved similar questions in the previous video lecture. So remember, whenever the range counters as mentioned here are rotating, okay, they rotate rapidly from 0 to a maximum value when the DME receiver is in the search mode. The DME receiver will be in the search mode when it is trying to achieve a lock on with a particular or any nearby DME, any nearby useful DME station, okay, to achieve a lock on for a range display, for a range information. So the range counters are rotating continuously. So they will rotate continuously until they find a successful lock on with a DME station, a successful connection with a DME station. So this indicates DME is unserviceable, wrong. DME is trying to lock on to a frequency, wrong. DME is trying to lock on to a range, yes. Delta, the DME is receiving no response from the ground station, so that is wrong. So the DME is trying to lock on to a particular range. Okay, there will be many DME stations around. It will lock on with that DME station which gives the most accurate range. So that is the right answer. Next, where a DME uses mechanical counters for showing the range, continuous rotation of the counters means what? Again, similar to the previous question, the DME is in the search mode. Yes. The DME is in tracking mode. No. The DME is in memory mode. No. None of the above, wrong. So DME is in the search mode. Next. 73. Consider the statements on horizontal or slant distance when using DME. Remember, let's say here is your aircraft in the atmosphere and this is your DME station. Now, DME, the range indicated by DME is the slant range. This is the height of aircraft and this is the horizontal ground range. That's the range you are away from the DME. So let's label this height of your aircraft, slant range, ground range. Okay, this is diagram number 1. Now when your aircraft is directly overhead the DME station, what will happen when it is directly overhead the DME station? There will be no ground range. There will be no ground range. This ground range will be 0 because aircraft is directly overhead the DME station and whatever height of aircraft above the DME station, height will be represented as height will be represented as slant range. Height will be represented as slant range. Next, another diagram. Let's say I will draw 3 diagrams. One here, one here. Now, when aircraft is, let's say, pretty close to the DME station but not overhead, okay, in that case, this will be the slant range, this will be the height, this will be the ground range. Now, when aircraft is further away from the DME station, slant range will be somewhat flattened like this. Height, this will be the ground range. Again, when aircraft is again more than further away from the DME station, somewhere here, again the slant range of this aircraft will become more flat like this. Okay, so as the aircraft goes away and away from the DME station, the angle, this angle between the slant range and ground range goes on decreasing. It goes on decreasing. So that means as aircraft goes away from the DME station, the difference in values, the difference, the difference in values between land range and ground range will be minimum. Okay, it will go on decreasing. Let's say the difference in values will go on decreasing, will go on decreasing. At one point of time, when the aircraft is away from the DME station, much away from the DME station, and at the same level as the DME station. Now, aircraft we all know will be flying above the DME station, but theoretically, when it is very far away from the DME station and at the same level as that of the DME station, in that case, the horizontal ground range and the slant range both will be equal in value. But that will not happen because aircraft will definitely fly above the DME station, not at the same level as the DME station. Okay, so the correct answer here will be, let's check. The horizontal distance is always slightly longer than the slant distance. No, not always. There may be situation, like I said, when aircraft is flying at the same level as that of the DME station, the horizontal distance and the slant distance can be equal. The difference between them is automatically compensated in DME component. No, the operator in aircraft should always make a mental increase to indicated range. Now the DME indicates slant range, okay, not the ground horizontal range. In order to compensate for the difference between horizontal distance and slant distance, no. So remaining option is Charlie. The difference between horizontal distance and slant distance will be negligible for en route navigation. En route navigation is cruise navigation. When you are very far away, at least 200 nautical miles away from the DME station, okay. So when the indicated distance is more than the height of aircraft in thousands of feet, okay. So when you are 200 nautical miles away, let's say you're 200 nautical miles away from the DME station. Ground range is 200 nautical miles away, and you are at a height, flying at a height of 36,000 feet. 36,000 is nothing but 6 nautical miles, right? So 6 nautical mile is definitely less than 200 nautical mile. So answer is Charlie. The difference between the two distances, land distance and ground distance, will be very small for en route cruise navigation when land distance is more, okay, than the height of aircraft. Okay, when the indicated distance is more than the height of aircraft. So I have taken ground range. You can also take it to be slant range because the difference between them will be negligible. So both ground range and slant range can be considered to be equal. So yes, so range is more than the height of aircraft, which is 6 nautical miles. Next, a VOR and DME are frequency paired. The DME identification ends with letter Z, Zulu. This denotes what? Very important. When the DME station and VOR station are not associated with each other, that means they do not satisfy any of these three conditions but serve the same location. That means VOR station in Mumbai, there is a DME station in Mumbai as well, but they are separated from each other by more than 2000 feet. In that case, they will be said not to be associated or disassociated with each other, and the frequencies will still be paired. That's fine, but then how do you differentiate between them or their identities? The first two letters are the same. The last letter for DME is Zulu. Okay, first two letters are the same. So for VOR identification and DME identification, the first two letters will be the same, but the last letter will be different for VOR and different for DME. In case of DME, the last letter will be Zulu always. That means VOR and DME are not associated with each other. So the two beacons are greater than 2000 meters apart. It is 2000 feet apart or 600 meter. Okay. Bravo. The two beacons are co-located. No, they are not co-located. The two beacons are supporting the same site in same location, but are not co-located. Yes. The beacons are at the same location. No, but more than 1000 meters apart. That is wrong. So Charlie is the most suitable option. The most accurate measurement if ground speed by DME for aircraft at 30,000 feet will be when? Now I have told this before in my previous lectures. The indication ground speed indication will be accurate when you satisfy this particular following conditions. Number one condition is that aircraft must be flying directly towards or away from a DME station. Okay, directly towards, okay, or away, not parallel to it, not across it. Next, aircraft must be as far as possible from the DME station. Okay, these two conditions are very important. So option A will be wrong because aircraft must be very far away from the DME station, as far away as possible. Passing a beam, just it should be passing. It should not be passing a beam. A beam means is this is if this is your DME position. Look here, DME equipment on the ground. Okay, DME station. Aircraft must be flying directly towards it or directly away from it. It cannot be flying parallel to it. A beam means parallel to it or across it, 90 degrees. Tracking towards the beacon, yes. Tracking away from the beacon, also yes. So next, check the second condition, which is aircraft must be as far away as possible. So option C, you're 10 nautical miles away. Option Delta, you are 100 nautical miles away. So 100 is more than 10 nautical miles. So correct option is option Delta. Do watch my previous lectures in which I have also explained how ground speed calculation happens in DMA. It's nothing but speed equals to distance upon time concept. DME gives you the distance information. Okay, you can calculate the time. Okay, the time it takes to change. So the DME equipment will come to know speed by checking how fast you are flying or how fast the distance between your aircraft position and the DME station position is changing. So the rate of change of the range between your aircraft and DME location will be interpreted as speed, distance upon time. In which of the following bands does DME operate? DME operates in the ultra high frequency band 962 1213 megahertz. Next, 77. DME is a secondary radar. Very important, I have explained this many times, which provides slant distances between aircraft and a ground station transponder. In case of DME, your aircraft is the interrogator transmitting at 1090 megahertz. The ground station, the ground transponder will reply to that at 1030 megahertz. DME pulses are transmitted in pulse pairs like this. Okay, why is that? To increase the range? No. To prevent lock onto the ground? No. So that pulses are squared and identified? No. So that radar emissions do not interfere with DME equipment. That is right. So DME is a secondary radar, but now there is another kind of secondary radar called secondary surveillance radar, which is used for precision approaches, and other things, surveillance, monitoring, supervision. So that radar emissions, which are not pulse fed like DME, those radar emissions should not be interfering with DME emissions. That's why the difference. So that radar emissions don't interfere with DME equipment. By using a random PRF, random pulse repetition frequency, this is called jittering. Jittering. What happens? So jittering is done so that DME, the distance measuring equipment on board your aircraft, will only accept those pulses which are unique to itself, and it will reject those pulses that are not meant for itself, that are meant for other aircraft. So every aircraft will have its own pulse pairs which are unique to itself. So recognize beacons reply among a mass of ground returns. So this is done. So this is another advantage that DME only accept reply pulses coming from the DME ground station and rejects all those pulses which are mere reflections from the ground. And how does it achieve this? Because DME is based on secondary radar principle, and secondary radar operates on two different frequencies. Ground reflections will be happening on the same frequency. So that is how it comes to know. Next, prevent interference from random transmissions. Distinguish between its own replies and replies meant for other aircraft. Yes. Reduce the effect of weather interference. Wrong. Aircraft DME receiver is able to accept replies to its own transmissions and reject those to other aircraft because of the jittering of PRF, pulse repetition frequency. Pulse pairs are amplitude modulated. No. Transmission frequencies are 63 MHz different for each aircraft. No. 63 MHz different from aircraft and the ground transponder. Aircraft interrogation signals and transponder response are 63 MHz different. No. The time interval between pulse pairs is unique to each aircraft. That is right. So this concludes our lecture. I hope you have understood all the 10 questions. Very important for CPL writing, CPL written exams, ATPL written, and your airline entrance exams. So do this chapter very carefully and thoroughly and practice many questions like with me. Okay, so your concept will get more clarified and your confidence will also boost up. Do let me know your questions, comments, feedback in the comment box. Please share this video with your friends and like this video lecture and subscribe if you haven't yet. Thank you for your time.